going to stay on the board here for just a few minutes because I really want us to concentrate on these multiple paths that router 1 has to router 3's loopback and to router 4's loopback, and why these particular paths were chosen. Now at the top of the screen right now, I do have the full BGP table for router 1, but then at the bottom here I've got the 2 entries for router 3's loopback. And one of them has been marked valid and best. The other one's been marked valid, so maybe there's no problem with it, but maybe there is. And as we look at this, if you don't have that entire list memorized that we just went over at the end of the last video, that's okay for now. I would know it for the exam. But I'm going to give you a little bit of a clue as to what's going on here with this path selection. I personally guarantee you that the BGP RID, the last step, does not come into play. Okay, so something's going on here in that path selection, maybe. And I'll shut up now with all of that, and we'll go down here and look at router 3's entries, or router 1's entries for router 3's loopback. We know the first value that BGP considers in the best path selection, it's weight. We know that's a Cisco proprietary attribute. Both paths here have a weight of 0. Nothing tricky there because we can look and there's a column weight and a couple of zeros under it. Now, you might think I'm being a smart aleck by putting it that way, but the second value considered is local preference. We know the highest local preference is preferred, but the path chosen as valid and best has no local preference listed. The path not chosen has a local preference of 100. Now you might look at that and say, oh, okay, you know, that other one's got a local preference of 0. Well, the Cisco default value for local preference is 100. We have a full section coming up on local preference in a couple of labs, and the number 100 will be burned into your brain, but I just want to introduce that now because we need to know that local preference is a tie as well. So why was one path chosen over the other when it looks like every single value is the same? We'll come back to that, as a famous detective used to say, after taking a closer look at the paths for router 4's loopback. And we really have the same situation. The weights are both 0, so we know the highest local preference is the next value considered. That's what we're looking for. The path chosen, again, has no local pref shown, so it's at the default of 100. This is just something you got to get used to. It just happens sometimes. You'll see local preferences not showing or metrics not showing. You'll see what a metric is later in this section as well, but we need to know the local preference is the default of 100. So why did BGP choose the path with the next hop 172.12.123.3? Kudos to you if you nailed this, especially if it's the first time you watched a video. If it's the second time you watched a video, you really should have nailed it. Well, it does go back to something we were talking about before, and that is a router knowing where a given address is, or not knowing where it is. And what I've got on the board here, let me show you these commands fresh. Show IP BGP 3333. This is the extended version of show IP BGP, and it can be really a handy command. I start my troubleshooting and just getting used to a network and a test environment with show IP BGP, but this is great because it shows you how many paths are available, which one was chosen as best, who it's being advertised to, all kinds of local pref, valid, internal. Notice here the local pref for each one of these two paths is 100. Notice this one was marked as best. And why? Because of this. And this is why I love this command. This goes back to what we were talking about before about a router knowing where a next hop IP address is or not knowing where it is. Well, the thing is, the next hop for this given path is 172.12.234.3 for router 1. And router 1 says, hey, I don't know where the 172.12.234 network is. I can't get to this address. I don't have an entry that even begins to match it. Because remember from our previous video and the IP addressing, router 1's directly connected to the Ethernet segment, 10.1.1.0/24. It's directly connected to 172.12.123.0/24, but it's not directly connected to 234.3, and we're not running any protocol that would let router 1 know about it. We're not running OSPF, RIP, or EIGRP, and we didn't put a static route on. So immediately, router 1 says, I don't know how to get to 234.3, so I'm not even going to consider this route. So that's actually how 123.3 got chosen. And I did not mean this as any kind of trick when I show you this right after the best path selection process. It's just a reminder, and you're going to get more than one reminder in these labs, that what tends to confuse people in BGP configs or cause some troubleshooting is inaccessible addresses like this. Sometimes it really is that simple. And let's go ahead and run show IPBGP 4444, and you're going to see much the same thing, that it shows one path out of the two because the other path had an inaccessible next hop IP address. Good stuff there. Good stuff. Now let me scroll down here a little bit. This is all the same information, but I want to go back to these next hop addresses because that may seem a little odd to you. And I've got some diagrams here. It's going to kind of remind us about the IP addressing in a moment. But here's my question. You know, the next hop addresses of the routes learned from router 2, why are they 123. Why are they 234.3 and 234.4? If we're learning it from router 2, why doesn't the next hop IP address change? And let me show you exactly what I mean by that. Now, the one I've got here on the screen, I'll keep it there. These are the routes for router 3's loopback. Well, router 3 is advertising it to router 1 across the cloud, across that adjacency. So the next hop is 172.12.123.3. Makes perfect sense. Router 3 is also advertising that route to router 2, and the next hop IP address is 234.3, of course, because that advertisement's over the Ethernet. Makes perfect sense. But here's where it gets a little odd. Router 2 then advertises that same route to router 1, and we like that. But the odd thing is the next hop IP address remains the same at 172.12.234.3. We saw it in the BGP table. That's really weird. Why doesn't it change? Router 2's interface that it's advertising to router 1 on is 172.12.123.2. We know that. Why isn't that the next hop IP address? Well, we have the same thing going on with 4444, because when router 2 learns that route from R4, the next hop IP address is 172.12.234.4. Makes perfect sense. But then as we see, router 2 is advertising that loop back up to router 1, but the next hop IP address remained the same at 170.12.234.4. So that's really that's what's causing the inaccessibility that we saw with show IPBGP 3333 and 4444, is that for some reason the next hop IP address isn't changing to the interface that router 2 is using to advertise the routes to router 1. Pretty odd. It's a mystery, but it's a mystery we're going to solve on the very next video. See you there.